Hi, welcome to clickmyproject.com. Now we have to see the process of creating evaluating user behavior profiles automatically. Here is the abstract of our process. The main objective of the paper is creating and evaluating user behaviors and also propose a genetic approach to evaluate user behavior based on sequence of events. Here, the events are stored in a trie system for easily classifying purposes, and it's also very computationally efficient and fast. The structure is also simple and interpretable. So that we propose a new approach for creating and recognizing automatically the user behavior of a computer user. So the computer user profile is represented as a sequence of commands. Here he types doing her or his work. The sequence is transformed into a distribution of relevant subsequence of commands in order to find out a profile that defines its behavior. So as the user behavior evolves or changes, an evolving method is used to keep update the created profiles using an evolving agent behavior classification based on distribution of relevant event approach. Based on these approaches, then the user profile changes, it is transformed to the relevant subsequence of commands, so that we have to find easily the user profile whenever it changes and also identify the user behaviors. Here is the DFT of our process. Here first recognize the command line dataset. Here we select the input dataset. The dataset is based on the command lines. And then evaluate this profile to library. So that command line datasets are stored into the database for evaluating the user behavior. Then move to segmentation of sequences from the command. So from the command line dataset, we have to identify the segmentation process. In segmentation process, we have to calculate the delimiters of the process. We have to remove the delimiters. We have to only identify the commands. Then move to the subsequent of length of trie. Here, after removing the delimiters of the process, the subsequences are stored in a trie storage system. Trie storage system, its length is also denoted. Then user profile creation trie. This shows the simple representation of user profile creation based on the subsequent length. It is displayed in the trie storage system. Then finding the relative frequencies for subsequences. Then based on subsequent length, we have to find the relative frequency of subsequent length. Which user profile has the same relative frequency based on the behavior. So prototype representation of snapshot. This prototype representation denotes the user behavior based on the subsequent length, and also we have to find out the potential range of the sample data. This potential range is used to classify the irrelevant user behaviors based on the relevant user behaviors. So the user behaviors changes from according to the one environment to another environment means thus behavior is reported in the potential range calculation. Based on the potential range value, the user behavior is identified and evaluated. So in prototype representation of sample class, the user behavior, the irrelevant user behaviors is stored in the prototype representation. So based on the potential range value, the irrelevant behavior is removed in the prototype, so that we have easily identify the user behavior and cosine distance comparison for classification. After classifying the user behavior, we compare the behavior of the original user and the irrelevant user behavior, so that we have to easily identify and classify this behavior of the user is irrelevant to the original user behavior, so that we easily classify the user behaviors. So that based on the user behavior classification, we have to represent the performance evaluation of the user behavior. Here is the demo of our process. Here select any one of the datasets and profiles here. Here the experience program list is verified and successfully stored into the database. Then here select the experience program, any one of the experience programmer user profile, and the behaviors are listed below. Then the particular experience program behaviors are listed. Then we calculate the range evaluation of the selected behavior. So here's the subsequent length is 1. So It is also displayed in a try storing system. It is easy for classification purposes. Here subsequent identification. Here select any one of the experienced programmers. So the sublength are calculated for every command for the user experience to user command's behavior. And then evaluating is here relatively frequency of variation for that behavior. So that we have summarized the subsequent length. Here the experience 15's programmers commands are evaluated and the relatively frequent behaviors are identified and the count values are displayed in the summarized behavior. Then potential recursion. Here is calculated for potential value for every frequency 11 behaviors. So that potential value is calculated for the each and user behavior. Then later relevant subsequences. Here relevant subsequences means here denote the graph of the user command behaviors expression. Here the frequency of them. Here the user behaviors, which user has the high relevant frequencies and denote the relevant frequency of the user behavior. Then move to next process. Here the irrelevant frequencies are identified so that it is removed in the feature reduction process. Select any one of the user behavior and feature reduction. Here the total types of prototype. These are the behaviors are irrelevant compared to the original user behavior. These prototypes are identified and removed. Then move to the next process. Here the experience 15 user behavior 10 experience 15 users 10 commands are irrelevant to the original user behavior, that is removed and analyzed, so that we have to easily classify the user behaviors. Thank you.